A very good morning, one and all. Am I audible? Okay, so very good morning to one and all. So last class we have seen about the steam power station or thermal power station or coal fire generating units. All are same. Okay, so we have seen about okay, what are the major arrangements that is happening in the steam power station. Okay, as I already discussed, okay, so this steam power station, okay, so needs more workers, okay, more workers for operation. Okay, so this running a steam power plant is not at all a very easy task. Like you can simply run a generator or okay, not only one or two is needed. As I already said, for the whole plant operation, okay, for the whole plant operation, okay, minimum you need 200 members, okay, 200 employees to the maximum of 500 employees. Some of the power station they are going for 500 employees for 3 generating units, 4 generating units. Okay, so minimum for running a plant you need more number of employees, and also if you see like the amount of salaries, okay, salaries. That is maintenance cost, operation and maintenance costs also very higher, because for maintaining this we need to spend more more rupees, more amount for running the plant. Okay, running cost is very high, okay, because you need to pay for the wages, pay the wages for the daily employees. So minimum 30,000, 40,000 if you need to spend for each employee means imagine about the 200 employees, 300 employees. Okay, so that much amount of rupees is needed for running the whole plant. Okay, so once again I am repeating this block diagram. So while drawing the block diagram, this arrow mark is very important. Okay, arrow mark is very important. So from where the whole say for example, if you are drawing this block diagram, whole block diagram, try to draw it in landscape. Okay, turn your page and try to draw in the landscape mode. So if you see the block diagram, so first it is starting from the coal storage plant. Okay, coal is stored in a coal dump yard. Okay, we call it as coal dump yard. So not only kilograms of coal, it is tons and tons of coal. Tons and tons of coal stored in a particular place, and from where it is being taken to the coal handling plant. Okay, coal handling plant via some conveyor belts. Okay, coal handling plant. So in there, coal is being crushed into. We call that coal as pulverized coal. Okay, pulverized coal means the coal is being crushed. Okay, crushed for, instead of directly take, because after mining, if you see the coal, it will be of 10 mm, 12 mm, like that. Some random sizes might be there. Okay, so simply like that, if you take that coal, it weighs about 50 grams or 25 grams, 100 grams. It depends on the type of the coal. Okay, so simply like that, you can't fit into the oil. So what we are doing is we are crushing the coal into pulverized coal. We are crushing. We are making some powder like, okay, not fine powder like, for better efficiency in the furnace. Okay, why we are able to we are going for pulverizing means to get the maximum efficiency in the furnace. Okay, so that your water also will be heated up in the very high temperature. Okay, high temperature, as I already said. Okay, so in the boiler, if you see like the temperature might be of some 600 degree Celsius, minimum 600 degrees Celsius to maximum 1000 degree Celsius. Okay, so that much heat is generated in the boiler. So water is getting boiled up. Okay, so again it is passed to the. So this arrow mark is very very important. Okay, from here to cold. Okay, without that, simply if you draw the block diagram, okay, you will get only 2 marks in the exam also. Okay, so just see the ensure that you will be able to draw this block diagram or sorry arrow mark also. Okay, so it is fed into the boiler. After the boiler, it is that steam, okay, superheated steam is again okay fed to the superheater. Where again the okay your heated steam gets again heated up to some other degree Celsius, because what we are doing is we are trying to extract the maximum okay maximum heat from the flue gases. Okay, so some flue gases will come out from the boiler. So what we are doing is we are extracting the maximum heat. Okay, so that flue gases pass to the superheater. Okay, so that superheater, some heat is getting extracted, and this is the first stage of extracting heat. Again the same flue gas, say for example if you take a tube, so for example this is the tube. Okay, this is the tube which carrying the steam. Okay, so the first stage, it is passing over up to here. Okay, up to this point. Okay, so this steam is the flue gases pass to this point. Okay, so where in this part they are extracting some heat in the superheater. Again the same flue gas is passed to this stage. Okay, this stage is economizer. So in the economizer also, what we are doing is we are okay trying to maximum extract the heat, and also in the economizer this hot air. Okay, again it is blowing to the boiler. Okay, why we are blowing the hot air to the boiler means to extract the maximum efficient, because normally if you're okay if you're giving the if you're blowing the hot air to some normal air to boiler means, okay, so it will take more time to heat it up. Okay, so if you are blowing the hot air itself, okay, so easily it will catch the fire in the furnace. It will catch the fire, and easily the water also will get heated up very easily. Okay, so normally in our home, okay, for boiling 100 degrees Celsius of 1 liter of water, it takes some minimum 5 minutes or 6 minutes to maximum of 10 minutes. Okay, for heating our water to 100 degrees Celsius. Imagine you want to okay boil that water to 600 degrees Celsius. So you need more time. Okay, so more time for heat the water to get heated up. So if you are blowing hot air means, so instead of taking okay some 10 minutes in the boiler, it will take around the time will get reduced. Okay, so that also we are extracting the heat here. So again the same okay some flue gas is passed through the air preheater. Okay, so where air is getting preheated. Okay, air is getting preheated, again we are blowing the hot air to the boiler. So maximum hot air is fed into the boiler. So okay, steam also you can able to get it very soon. Okay, so sometimes this hot air, okay, hot air also okay blown to the forced draft fan. Okay, some normal air is okay it is given by a forced draft fan. Okay, again this flue gases pass to the chimney and okay, so if you see like chimney, it will be of some 100 to 200 okay meters. Okay, 100 to 200 feet height. Okay, so that much okay height what we are doing is we are taking the flue gas into that much height, so that it is not not okay, mixing with the normal air. And also we are also inhaling, no? So nearby many houses are there. Okay, many human beings, living creatures are there. Okay, so they will not get any harm. But even though some toxic gases are there, already I said some, the fume consists of some toxic gases like NOx, okay, then SOx, okay, nitrous oxide, sulfur dioxide, and then carbon monoxide. Okay, like that, so many harmful gases are there. So even what we are doing is we are treating that flue gases again, and we are sending the flue gases, okay, from the chimney to some permissible limits. Okay, that is some permissible limits from the your pollution control. Okay, so this here, if you see, like this from the superheated steam is okay. So this will be generated, and it is going to the valve. I already said what is the usage of the valve. Okay, depends on the demand. Our demand is at the um, at the okay outlet, like in the load in the bus. Okay, say for example, 1000 megawatt is the 1200 megawatt is the demand in the bus. Okay, so what we are generating is so only 1000 megawatt. Say for example, this whole plant may able to generate around 1000 megawatt. Okay, so 200 megawatt is deficit. Okay, so either you will get some okay command from the load dispatch centers to increase the generation, or what they will do is they will ask them to okay 100,000 megawatt is itself enough, or they will tell us to on some other 500 megawatt another additional generator, okay, due to the ever increasing demand. Okay, so after this valve it is heating the turbine. Okay, turbine. So that turbine is coupled with the alternator. Okay, so in alternator I already said, okay, alternator I already said you may able to generate around 11 kilovolt or up to 25 kilovolt. Okay, so what they will do is that 25 kilovolt is the step up transformer. Transformers already studied in electrical machines 1. Okay, so in this step up transformer, what it will do is it will step up 11 kV or 25 kilovolt into 400 kilovolt. Okay, so that 400 kilovolt is being given by a, so this isolator, circuit breaker and all you'll be studying in the protection. Okay, protection subject. Okay, so in that okay, isolators for isolating this bus bar. Okay, so it is being directly given, so circuit breaker also that for any fault clearance. Okay, and it is directly given to the bus bar. So three phase RYB of 400 kilovolt is being transmitted over very large distance. Okay, and it is being utilized in the substations. Okay, so again, so in the superheated steam, okay, some after okay, in the steam will hit that turbine. So after that some exhaust steam will be coming. Okay, so exhaust steam get condensed. Okay, condensed in the condenser. Okay, so say for example that in the turbine, okay, the superheated steam will be of around some 500 degrees Celsius. Okay, so in that 500 degrees Celsius, after exhausting, so it will lose some heat. Say for example, you are getting around 100 degrees Celsius or 200 degrees Celsius. Okay, so either what they will do is in modern thermal power plant, what they will do is it is having a feedback. Okay, so the exhaust steam again they fed into the same turbine. Okay, because so once if you send out that steam will also get wasted. So again that exhaust steam again is fed into the boiler. So again it is fed into the turbine. So what we are doing is we are extracting the maximum, okay, maximum mechanical energy out of that. Okay, maximum. So that is of modern power plant. Okay, so in this power plant, what they are doing is they simply exhausting. You can also add one more. Okay, one more arrow mark to boiler or either to the turbine also feedback. Okay, nothing wrong with that. So this exhaust steam is fed into the condenser. So in condenser, what is happening is, so that exhaust steam, say for example, 200 degrees Celsius, again what they are doing is condensing. Condensing, okay, in condensing. So some that steam will convert into some water particles. Okay, some water particles after collection. Okay, so after collection, it is being given to the cooling tower. Is being given to the cooling tower. So from the cooling tower, again it is passing to the circulating water pump. So why they are passing to the circulating water pump means, okay. So in the cooling tower, okay, one minute, I will show you. So when it is not showing. Okay, in offline classes, I will explain you that. Okay, so in this cooling tower is being okay given to the circulating water pump. Okay, so again, so water is being circulated to the condenser again, and the same water. Sometimes the same water again it is given to the condenser again. The same water. Okay, same water. What we are doing is we are pumping again. We are giving the same water to this economizer. So in this economizer again the flue gases is there. So from that flue gases again, so the water is somewhat getting heated up. Again we are giving the heated water to the boiler. Okay, heated water to the boiler. Again the same water is being fed to the boiler also. Okay, so boiler also. So sometimes what they will do is they will check the pH value of the water here. Okay, so if the pH value of the water is again it is decreasing or increasing like anything, what they will do is again they will give that same water to the water treatment plant. Okay, in the water treatment plant, so water is being oxygenated, and some scale formation will be there, and also in the boiler some impurities will be there. So that impurities and all, what they will do is they will simply they will filter all the impurities. I think already you studied in your chemistry, engineering chemistry. So in that how to treat the water. Okay, so the water is being treated, and again it is fed into the river. Okay, so cool water is fed into the river. Okay, they will not simply they will let out that hot water to the river. Why? Because so in river also many species are there. Okay, if you simply give the hot water to the river or sea, okay, so there it will spoil the life of the species also. So okay, so that also they will consider. Okay, so if you see like so here the pulverized coal is fed into the boiler but by belt conveyors. The coal is burnt into the boiler, and ash produced by the boiler after complete combustion is removed to the ash handling plant. Okay, so separate ash handling plant also there. Here after the furnace, okay, that ash is being transferred to the ash handling plant. Okay, so via some conveyor, and ash is being stored to the some ash storage plant. Okay, so that ash can be used for in making the cements, okay, and roads, concrete structure, something like that. They might be using that ashes also. Okay, so dual purpose because it is not simply get wasted up. Okay, and also what they will do is they will test the ash. Okay, ash also here. Okay, so if the ash still having the quality of burning, so what they will do is again they will take again they will filter and they will take that ash to this boiler, that is furnace. Okay, for heating. Okay, so that also possible here. Okay, so if you see here, a 100 megawatt station operating at 50% load factor. So load factor, I will tell you, may burn out about 20,000 tons of coal per month. Okay, per month, 20,000 tons of coal. Okay, imagine it is 1,000 megawatt. So it is increasing about again 10 times. Okay, so again 10 might be added. Okay, say for example 10 added means it is around 2 lakh tons of coal per month. It is used like it is utilized for 1,000 megawatts, 1,000 for generating 1,000 megawatt of power in a month for 30 days. Okay, and ash produced maybe of tune up to 10 to 15% of coal fire. That is okay. Ash content in the outlet you may get 2,000 tons to 3,000 tons of ash you can get as in the outlet. So this ash again being utilized in the some concrete cement factories like that. So thermal station about 50 to 60% of total operating cost consists of fuel purchasing and handling. Okay, so in thermal power station, so the cost, okay, operating cost of fuel purchasing, handling itself taking 50 to 60%. And again for salary, again 30% and operate maintenance, and operation maintenance, again 10 to 20%. Okay, so that is the thing. Okay, so what is the need of boiler here? So boiler is simply the heat of combustion of coal in the boiler is being utilized to convert the water into steam. Okay, water into steam at high temperature and pressure. Okay, high temperature and pressure. Okay, the flue gases from the boiler makes this journey through the superheater economics and air preheater, and finally exhaust to the atmosphere through the chimney. Okay, and finally, so it is given to the atmosphere. Okay, so what is the role of superheater here? The steam produced in the boiler is wet. Okay, is wet and is passed to the superheater where it is dried and superheated. Okay, so from the boiler, steam is being produced, even though that is also superheated steam. So again, what we are doing is again we are passing to the superheater. Okay, to take some wet particles, the steam. Again, we are removing some wet particles because to get the maximum efficiency. Okay, so if the wet steam is hitting the turbine means, okay, sometimes your turbine blades will be getting rusted up. Okay, so even it is of stainless steel. Okay, so even they will go for maintenance once in a month, twice in a month. Okay, so because simply it is always okay, it is getting wet, no, 24/7 or not even 24 hours, sometimes 18 hours. Okay, it is being wet, no. So that is not good for your turbine also. Turbine. Okay, so that's why what we are doing is, so via the superheater, we are taking some wet particles also. Okay, so superheating provides two principal benefits. So overall efficiency also increase. Okay. Secondly, too much condensation in last stages of turbine. Okay, so too much condensation is some water molecules. Sometimes it will stay in the turbine also. That also will be avoided. So corrosion, it causes blade corrosion. Okay, blade corrosion means again and again you need to replace the blade. So again and again if we replace the blade means, so operation cost will get increased. Okay, maintenance cost and operation cost will get increased. Okay, so some workers has to replace the blades, and some workers has to Okay, we have to keep order to buy a new turbine base or replacement. So that is somewhat getting cost. Okay, our unit cost is getting somewhat costly. So, we have to maximum utilize the steam, and also we have to very okay. We are very concentrating on this steam also. Okay, so economizer is essentially a feed water heater. Okay, water heater, and derives the heat from the flue gases. Okay, so instead of giving normal water, okay, normal water. Okay, so normal water, normal water. So instead of giving normal water to the boiler, what we are giving is we are giving hot water to the boiler itself. Okay, so efficiency of the boiler still it can increase. So how we are getting heated up water means via the flue gases. Okay, flue gases, simply we are letting that flue gases out. No, so we are maximum extracting the flue gases. Only thing is that some emissions might be there. Uh, Apart from that, we are maximum extracting all the heat from the flue gases. Okay, and also if you see that thermal power station chimney, okay, chimney, that is outlet of the flue gases. So simply some fire will be, okay, some fire will be coming out from that chimney. Okay, so if you see in the night time, you can really see the some fire from the chimney. Okay, so in the daytime, if you see also, it will be like somewhat steam like that. Okay, but it is getting fired up. Okay, so why you find out in tomorrow's class? I'll be randomly asking somebody. So why you have to find? Okay, so next is air preheat. Okay, so air preheater increases the temperature of the air. Okay, supplied from the coal burning by deriving the heat from the flue gases. Okay, so what we are doing is we are simply preheating the air, reheating the air via the air preheater. Okay, we are deriving the heat from the flue gases. Okay, so air from the atmosphere, what they are doing is they are getting from the draft fan. Okay, post draft fan. Okay, and this passed before it is supplying to the boiler furnace. Okay, so we are giving the hot air to the furnace, hot air to the boiler furnace, so that the efficiency of the furnace will also get increased. Okay, instead of taking, say for example, it is taking 5 minutes or 10 minutes to get heated up. If we are blowing, it is catching the fire or very fastly in some, say for example, in 7 minutes or 6 minutes. So that 4 minutes, okay. So we can utilize some other heat also for heating the boil. Okay. So here the air preheater extract heat from the flue gases and increase the temperature of the air used for coal combustion. Okay, for coal combustion also it is very essential. Okay, so the principal benefits of preheating air are increasing the thermal efficiency. We are increasing the thermal efficiency, as I already said, and also increase steam capacity per square meter. Okay, steam capacity also will be increased. Okay, so automatically, if we are giving preheated air heats, so steam capacity also we are increasing. Okay, so that also we are doing. So next is steam turbine. So steam turbine, the dry and superheated steam. Okay, so the superheated steam is dried. Okay, so how it is being dried means from the superheater, again the steam is being dried up. Okay, and fed into the steam turbine via the main valve. Okay, so I'll show some video so you can better understand. Okay, some valve will be there. There are many effects in that valve also. Okay, that I can explain you. So the heat energy of the steam when passing over blades of the turbine is being converted into mechanical energy. Okay, so that superheated steam is okay, pass to the blades of the turbine. Okay, that is being converted into mechanical energy. So that steam is hitting the turbine in some speed. Okay, say for example 100 kilometers per hour. Okay, 120 kilometers per hour, 150 kilometers per hour. It is hitting the brakes. Turbine is being rotated. Okay, so if the turbine is rotated, it is automatically you can get the it is fed to the alternator path. Okay, so this steam exhausted to the condenser, which condenses the exhausted steam by means of cold water circulation. Okay, so after that, so exhausted steam, so we are condensing already we have seen and alternating. So coming to the alternator, steam turbine is coupled to the alternator, which converts mechanical energy into electrical energy. Okay, alternator. I think you are going to you are studying in electrical machines too. Okay, the working principle, everything. Okay, so the electrical output from the alternator is delivered to the bus bar, to the transformer, circuit breaker, and isolator. Okay, so this we are going to study. Okay, so how it is being transferred to transformer, circuit breaker, isolators, everything we are going to study in forthcoming topics. Okay, so no need to worry. It's a feed bottle. Okay, the condensate from the condenser is used as a feed water to the boiler. Okay, sometimes the same water is we can take to the boiler also, condensed water. But simply thing is that again we have to note down the pH value of the water also. Okay, so sometimes if you take the pH value of more, so simply in the boiler, the scale formation will be there, and again it will reduce the efficiency of the boiler and also the whole overall system also. Okay, so that also we need to take care of. Okay, so the feed water on the way to the boiler is heated by water heaters and economizer. This helps in raising the overall efficiency of the plant. Okay, so cooling arrangement. So cooling arrangement is very, very important. Yeah. The turbine is condensed. Okay. So water is drawn from a natural resource like river, canals, lake, and circulated to the condenser. Okay, the circulating water takes up the heat of the exhausted steam, and it itself becomes hot. This hot water coming out from the condenser is discharged to the suitable location down the river. Okay, so sometimes okay, this hot water also, what they will do is they are cooling this hot water and they are discharging that to river. Okay, so that will be some okay, okay, that is being passed. That hot water is being passed to the canal for some kilometers. Okay, so automatically it will lose the heat. Okay, and it is being given to the dams or rivers like that. Okay, so in case of availability of water from source of supply is not assured throughout the year, cooling towers are being used. Okay, so during the scarcity of the water in river, hot water from the condenser is passed to the cooling tower where it is cooled. So same cool water itself reused in the condenser. Okay, so sometimes, okay, so due to the in the summer season or not, so water scarcity will be there. So by the time what they will do is they will simply use the same water okay, from the condenser, same water, and again it is fed to the boiler also. Okay, so again choice of site for steam power station. Okay, so if you take like a choice of power, supply of fuel. Okay, supply of fuel, so it should be nearer. Okay, so I as I already said, okay, if you are if your coal steam power station, it is located near to coal mines now, so transportation cost will be very, very minimal, as we already okay see like this for purchasing the coal and the transportation itself taking 50 to 60% of the whole cost. Okay, so imagine if it is located near to coal mines, so the transportation cost. Okay, so nowadays, you know, the cost of diesel, 90 rupees. Okay, so 90 rupees. Okay, again, if you travel, if you take that coal for even 100 kilometers, 200 kilometers, the cost of okay transportation will be become like anything. Okay, so we are purchasing around 12 rupees, say for example 12 rupees. So again, transportation again 3 to 4 rupees per kg until. Okay, again, there for handling the coal, again some 18 to 20 rupees you are spending for per kg of coal. And the thing is that how can we expect per unit cost for 5 rupees or 6 rupees like that? Okay, so we are, because we are spending around a very huge amount for okay for this handling this coal around, but per unit cost is very less. Okay, so imagine that is also an important concern. Okay, important factors. This also, okay, supply of fuel. Okay, very important. Next is availability of water. Okay, so ensure that your coal power plant is located or get to canals. Okay, so that near to the dams, so that you can get that. Without water, the steam power thermal generator, that is steam power generating units, is not possible. Okay, water is also very important concern. Okay, so transportation facilities. Okay, so transportation facilities, it has to connected via rails, roads. Okay, as I already said. Okay, so from the coal yard, or from the port, from the shipyard to the thermal generating station, there will be, it is also connected with the railroads. Okay, same railroads. What they will do is, at certain stage they will connect this thermal generating station also. Okay, via a separate so that you can take the coal easily in the goods train. Okay, so in the power plant, what they are doing is simply the goods is single compartment. What they do is they derail all the compartments, single compartments. What they will do is they will just take that coal from that single compartments. Okay, inside the coal handling plant itself. Okay, so that also decreases the some okay some cost. Okay, because if you again dump into certain places, that is 1 kilometer apart or 0.5 kilometer apart. So again, that coal has to be traveled. Okay, instead of that, directly they are taking that compartments to near to the coal handling plant itself. Okay, so that also, and also by via roads. Nowadays, roads they are not doing as much, because you know the cost of okay fuel. So roads, if you take one load this many tons now, again the cost of fuel is going like anything. Okay, so rail is the somewhat less cost, somewhat cheap. Okay, and also the type of the land. Okay, so type of the land, if you want to okay install a thermal power station, so you need some huge okay huge amount of land. Okay, you need so where you have to bear that the cost of the land also. Okay, so and also heavy equipment also get installed. Okay, so you have to okay invest more amount on purchasing the land. Okay, so government, what they will do is some government lands they will take, and they will give to this electric board, or otherwise if it is private owned, they have to buy a huge okay, okay, amount of land. Okay, so that also is the cost and type of flat. Okay, so and also further extension. Simply say for example, you're installing 1000 megawatt of flat. Okay, in future we can't tell. It may able to extend up to 2000 megawatt, 3000, 4000 megawatt like that also. So 3 times, 4 times you have to purchase the land. So whatever, say for example, you are buying some 10 acres or 20 acres of land. Okay, for installing a thermal power plant of 1000 megawatt. So you have to buy some 4 times, 5 times. Okay, so that extension is easily possible in future. Okay, so by that time you can't able to buy nearby location also. So that also there, and also nearness to load centers. Okay, so that has to near to load centers. Load centers. If it is near to load centers, then it is well and good. Okay, the transmission cost also will be decreasing, and also losses. Okay, transmission or losses also will be decreasing. Okay, so that also there. So next is distance from the populated area. Okay, so as I said, as a huge amount of coal is burnt from the steam power station, some smokes and fumes will come out in the surrounding area. Okay, so if you are also located in particular near to the steam power generating units, that is coal fire generating units, you may able to find some smoke. Okay, so if you are trying some clothes, okay, in the terrace, okay, you may able to get some smoke fumes on your dresses. Okay, some cold contamination on your dresses. Even in drinking water, you can get even okay. So whatever the thing you are using, it will somewhat it will pollute, and also fumes. As I already said, it is harmful to human beings if you inhale that fumes. Okay, so simply like that you can get cancers, lung cancers like that. So that's why it is being given to very large. Okay, so large chimneys. Okay, very large chimneys are being installed so that you may not able to inhale it directly. Okay, maybe it is polluting the atmosphere. Okay, polluting the atmosphere, but not human beings. Maybe you may